A fluid is a state of matter that yields to sideways or shearing forces. Liquids and gases are both considered fluids. Fluid statics is the physics of stationary fluids. In physics, Pascal's principle says that given a fluid in a totally enclosed system, a change in pressure at one point in the fluid is transmitted to all points in the fluid, as well as to the enclosing walls. In other words, if you have a fluid enclosed in a pipe with no air bubbles and change the pressure in the fluid at one end of the pipe, the pressure changes all throughout the pipe to match.
You can break the bottom of a bottle glass using Pascal's law. Fill up the bottle glass with water until up to its neck. Then hit hard on the top part of the bottle.
An alternative explanation of this bottomless bottle is related to another physics terminology called cavitation. Cavitation occurs when the pressure in a liquid suddenly drops. This drop is caused by pushing a liquid quicker than it can react, leaving behind an area of low pressure, often as a bubble of gas. The water inside the bottle does not move down due to inertia, but briefly creates a vacuum at the bottom of the bottle. Cavitation creates larger bubbles which rapidly collapse. The collapse of these larger bubbles creates multiple smaller bubbles. These smaller carbonated bubbles expand rapidly.
Why using only our hands did not work? In most of the trials, we exerted force on top of the bottle using only our hands, and as seen in the videos, it did not work. We thought there were two possible reasons why striking the bottle using only our hands did not work. One, we thought that we were gripping the bottle in the wrong way, or maybe our hands were located in the wrong part of the bottle's neck. With this in mind, we tried and adjusted our hand placement around the bottle's neck several times. Another reason we thought that it didn't work because of lack of force. As seen in our trials, we tried to exert force harder than the last. However, we only ended up hurting our hands.